This is Unit 5, Lesson 1, Graphing Quadratics. All right, so we're just going to start off by reviewing some of the basic terminology that we've talked about this year and that you've also seen in the past. Okay, sorry, this thing. Okay, so your minimum, just a reminder, our minimum or maximum point on our graph is called our vertex. Okay, and of course, it's a minimum if your graph is a normal shaped U or it's facing upwards because your minimum gives you the lowest point. And then it's a maximum, the vertex is a maximum if your graph is a frowny face. It's upside down because then that means that your vertex is the highest point on your graph. All right, and we'll come back to reviewing how we know if it's going to be facing up or down in just a moment. All right, and the vertical line through the vertex is called the axis of symmetry. All right, because this is a line that we could draw straight down the center, and if you were to fold the graph in half on this line, this straight, the graph would match up. It's symmetrical on both sides. All right, now when we learn how to graph quadratics by hand, we use this form right here. And that's called our vertex form of a quadratic equation because it gave us all the important information on how to graph it. If your quadratic is given to you in the standard form, which is this one down here, you can't graph it using our special techniques of shifting sideways, reflecting, dilating, and all that good stuff. So later in this lesson, you will learn how to go between the two so you can easily graph a function. But our whole thing about shifting and moving and all that stuff only works when it's in the vertex form. And this is the way that we have seen it so far. So just a reminder, when you're given a quadratic, and we know it's a quadratic because there's an exponent of 2 of your x variables being squared at some point. But remember, our vertex is HK. All right, it is HK. And your axis of symmetry is x equals h. It's x equals that value. Because once again, if you're given y equals, and we'll make it basic, x minus 1 squared plus 2, we know that the opposite of negative 1, or just the h, just the 1, is your vertex. You move to the right. And then up 2. So your axis of symmetry is at this line because that is the lowest point. It's over here at 1, 2. So your axis of symmetry is x equals that x value, that h. And if your a is greater than 0, meaning it's a positive number, that means that your parabola is opening up. Okay, it's a happy parabola. If a is less than 0, meaning it's a negative, okay, we're not even talking fraction or whatever, we're just talking the actual value of it, it's opening down, meaning it's a frowny parabola, it's sad. All right, and then a reminder that the absolute value of a is greater than 1, then your parabola, what is it doing? Okay, it has a vertical stretch times whatever the a factor is. So what this is saying is that if the number, whether it's positive or negative, that all that tells us is which way it's facing. But if it's a number bigger than 1, okay, 2, 3, 1.5, if it's bigger than 1, it's vertically stretching. Okay, remember it's getting taller and skinnier by whatever that a factor is, 4, 2, whatever it may be. If it's a fraction, okay, once again, doesn't matter if it's positive or negative because that all that tells us is which direction it's going. But this thing, if it's a fraction, remember it's a vertical compression. Okay, it's getting shorter, you're compressing it down and wider at the same time, times whatever that a factor is. All right, now intercepts. Okay, we talked about these before. We are going to learn later in this unit how we can calculate them on the calculator. Yes, I said calculator. We will actually be using calculators this time around. But to find your y-intercept, if it's not on your graph, all you need to do is to plug 0 in for x and solve for y. Okay, and you can do that by hand. It's easier to find the y-intercept because even when you have things squared, plug 0 in and solve for y. Okay, so if it's not always on the graph, you don't always see it in the little snippet of the graph that we look at, you can easily plug 0 in for y, and for x, I'm sorry, do the math and you'll get your y-intercept. And then vice versa, for x, we plug 0 in for y and solve for x. Okay, and we know how to factor now, hopefully, so you can solve your quadratic by factoring, and then we are going to get into a review of the other methods on how to solve quadratics later this unit. All right, so that's just a review of our vertex form, which is what we've looked at in Unit 1 and 2 on how to graph a quadratic and all that stuff. So that should be a reminder of what those values mean, the h, the k, the a, and how that helps us move around. All right, now let's talk about standard form because it's a little bit different. It's a little bit, it's not harder, but it's different to graph it when it's in standard form. We can't just use our tricks of vertex and shifts and all this stuff because we don't see that information. It's not kind of pulled out and put into that form for us. So let's go through some of the basics here. So the same thing applies. If the a is greater than 0, so even though it's not in vertex form, we're still looking for if it's a positive or a negative quadratic. So if there is no negative in front, then it opens up, just like before. And if it is a negative, if our a value is negative, it's opening down, just like before. So that still is the same. Okay, and remember, your y-intercept is when x equals 0, and your x-intercept occurs when y equals 0. So to find those, we do the same thing. You can plug in 0 for y and solve for x, or x's if there's 2, because you could have 2 x-intercepts. You're never going to have 2 y-intercepts, though, and then vice versa. All right, so what's different here is where our vertex is, because I can't just pull that out. I can't just say, oh, it's the opposite of what's inside, and then the vertical shift on the outside is my y value, because we don't have that. We don't have an inside and outside here. So to find your vertex, the x value is going to be negative b over 2a. And we'll go through an example in a moment, and you can see what is meant by that. Your y value, it says it's the function of negative b is 2a. All this is telling you to do is plug the x back in once you get it and solve for y. All right, and once again, you'll see, we'll do an example in a moment. But once you find the x value, you're doing negative b, okay, this value right here, negative of that over 2 times a, okay, of the numbers, you get the x coordinate, plug the x coordinate back into the x's here and solve for y. All right, and once again, your axis of symmetry is the x value of the vertex, so it is just negative b over 2a. All right, so let's go ahead and let's actually find some of this stuff. We're going to mainly take a look at standard form right now because we've already done vertex form in our previous unit. All right, so looking at this first one, all right, y equals x squared minus 4x plus 3. I can tell that's in standard form because first of all, there's no parentheses. I don't have anything factored out. It's just ax squared plus bx plus c. So is this going to open up or down? Yes, it's going to open up because that's a positive x squared. Where is our vertex? Okay, so we can kind of take care of 2 and 3 at the same time because you have to find the axis of symmetry in order to find the vertex. So in order to do it, I'm going to come down here and do some work. We're going to do x equals negative b over 2a. This right here is going to give us my axis of symmetry. It's a line, and then it's also going to give me the x coordinate to my vertex. So let's take a look here. What is our value for a? A is 1. A is the coefficient of your x squared term. B is negative 4. That's the coefficient of your x term. And your c is your constant, the number that's all by itself. Okay, so when I substitute things, I'm saying the opposite of whatever b is. So if b is a negative 4, I want the opposite of a negative 4, also known as a positive, over 2 times a, so over 2 times 1. Okay, that just ends up being 4 over 2, or x is equal to 2. So that is the axis of symmetry. So I could then go to my graph and dash it in. I know that this is somewhere along here is going to be my vertex. Okay, we haven't figured out the y coordinate yet, so we don't know that, but that's where my graph is shifting sideways. So to find the y value of my vertex, I'm now going to take this 2 and plug it back into the equation in place of x. So I have y equals 2 squared minus 4 times 2. And please make sure when you're plugging it in, you're doing with parentheses. Here it wouldn't actually end up making a difference, but if I'm substituting a negative back in, it will make a huge world of difference whether you have parentheses or not. So get in the habit of anytime you're substituting a value back in, you are using your parentheses. Okay, now we have to simplify that. All right, so we've got y is equal to 4 minus 8 plus 3. Y is equal to negative 1. So that's telling me my vertex is at the point 2, negative 1. So right here, use a different color to find it. Woohoo! Okay, there is my vertex. Okay, so my y-intercept. So what we can do is we can plug 0 in for x and solve for y. Okay, so if I plug 0 in for x, I have y equals 0 squared minus 4 times 0 plus 3. I end up getting 3. What you'll notice is every time you're plugging 0 in, it ends up being your constant, okay, because your y-intercept does. Because I'm always plugging a 0 times that, 0, so it just ends up being the constant. So my y-intercept is at 0, 3, so we can go ahead and plot that. All right, my x-intercept. Okay, we're going to have to do a little bit of work here. So we're plugging 0 in for y. I'm going to kind of do it on the graph over here. And then we are solving for x. All right, well, this isn't too crazy. This is just a quadratic, so we're just solving that. So you're looking for two numbers that multiply to 3 and add up to a -4. That's -3 and -1, right? -3 times -1 is 3. -3 plus 1 is -4. And so if my factors are -3 and +1, that means the intercepts are +3 and +1. Factors and intercepts are opposite values always, because when you're factoring something, to technically solve this, we are then setting each of these equal to 0 to solve. So x equals 1. Okay, and remember, another name for zero or intercepts would be zeros or roots or solutions. Okay, they all mean the same thing, and we'll get more into that a later date, but we did talk about that in Unit 1. So in this case, I do have two. It's 1, 0 and 3, 0. All right, and so I can go ahead and I can draw this now. I mean, I know it's symmetrical, so I have another point here. Does this value have, or does this quadratic have an a value? No. And how do I know that? Because from here, it's up 1 over 1, which was our basic pattern when we graphed. There was no change. If it went up 2, there would be a dilation of 2 in front. If it went sideways more, it would be compressed out. But it's just that. So our vertex form is y equals x minus 2 squared plus 1. Wait, how did you know that? Oops, sorry, minus 1. JK. Because remember, we know where our vertex is. There is no dilation here. It's not upside down. That we know, okay? All right, let's take a look at our next example. All right, so let's look at this next example, y equals x squared plus 6x plus 8. So once again, this is a positive, so we're opening up. Our vertex is an axis of symmetry. We have x equals negative b over 2a. Our b value is 6, so x equals negative 6 over 2 times 1, which is 2. So x equals negative 3. That is our axis of symmetry. Our vertex is at negative 3. And then we got to solve for our y. So negative 3 squared plus 6 times negative 3 plus 8. Okay, so this one, we had the negative, so really make sure you put that in parentheses when substituting in. So negative 3 squared is 9 minus 18 plus 8. When I simplify that, I get negative 1. So my vertex is at negative 3, negative 1. All right, so I'm going to go ahead and plot that information on my graph, just so I have something there. 1, 2, 3. Here is the vertex. All right, y-intercept, plugging 0 in, or just realizing it's going to be 8, but I'll prove that to you. I'm telling you it's going to be 8. So if I plug 0 in for x, even if x had a coefficient, because if you square 0 and multiply it by a number, you get 0, right? So if you recognize that, that makes life easier. That doesn't fit on my graph. That's okay. X-intercepts. So we're just got to factor 8. Two factors of 8 that multiply to 6. And guys, you can use a box, but remember, we said that, hey, if x squared has a coefficient of 1, well, then it's just those two magical numbers are my factors. So this factors into x plus 4 and x plus 2. So that means that my solutions are, and we set that equal to 0. My solutions are negative 4 and negative 2. Okay, and by solutions, I mean my x-intercepts or my roots. They mean the same thing. All right, and if you notice, once again, if I regraph this, we can finish our pattern from here, we can always plug in more x values, but 1, 1, 1, 2, 3. So that helped me find my vertex. 1, 2, 3. And then also, if it's in standard form, guys, if you can just find the vertex using negative b over 2a and all that good stuff, and then you tell if there's a, what do you call it, a stretch factor or dilation, you know what to do. The a value is your stretch factor always, okay? So kind of probably should have brought that up to you before. Well, we did, but remember your A tells you if it's opening up or down, but it's the same thing here. So the A on your standard form is telling you if there's a stretch factor. So if it's just 1, you could, once you find that vertex, just graph from there using the pattern, up 1 over 1, up 3 over 1. All right, so just something to be aware of. So my vertex form, y equals x plus 3, because we shifted the opposite direction, right, down 1. All right, and then last one opens up. My vertex is at negative 4 over 2, so at negative 2. That's my axis of symmetry. Plug that back in, so y equals negative 2 squared plus 4 times negative 2 plus 3. So I get 4 minus 8 plus 3. Oh my gosh, they'll end up being negative 1, huh? So my vertex is at negative 2, negative 1. All right, y-intercept is going to be 3. I can tell from my equation. And then x-intercept is at, factors into x plus 3, x plus 1, right? 3 times 1 is 3. 3 plus 1 is 4. So therefore, my intercepts are at negative 3 and negative 1. I can make my points and draw my beautiful u. So y equals x plus 2 squared minus 1. All right. So even if it's given to us in standard form, don't make it harder than it needs to be to graph it. All right, part B, writing equations. So kind of going back with what we had said, the relationship between factors and x-intercepts, roots, solutions, another word would be zeros, is opposites. And that's super important to know, because if I give you a factor, you need to be able to write the equation, or vice versa. All right, so in this case, I'm giving you the x-intercepts, the zeros, the roots, solutions. All 4 of those words mean the same thing. It's where it's crossing your x-axis. Okay, intercept will be written in point form like you see here. Well, in this first one, a zero, solution, or root, it's just x equals 5, x equals negative 4. All right, so if I want to work backwards and I want to write the equation for this, think about this. This is where it's crossing. So we need to first change it to its factor. So if it's crossing the x-axis at 5, that means the factor is x minus 5, because they are opposites. If it's crossing at x minus 4, it's x plus 4. So if I'm writing the equation, I can set it equal to either 0 or y. So now I can just go ahead and multiply it out, and we're working backwards to get the equation. So x times x is x squared plus 4x, foiling, minus 5x minus 20. So x squared minus x minus 20 equals y. So even when I'm given the, either given the factors, I just multiply them out, or given the intercepts or whatever, I can write them as a factor, the opposite sign, and multiply it back out. Now you notice in our second one, all right, now in our second one, you'll see that we have i's in there. Okay, so that means that we had imaginary solutions. Let's think about the graph, and we're going to explore this more in the unit. But if there are imaginary solutions, remember your solutions are where it's crossing the x-axis. So if I have i's in my solutions, what does that mean? That is right. That means that it's not crossing the x-axis. It's something like this, where your u is either up or down or whatever, but it doesn't actually touch your x. So we can still solve now that we know how to work with imaginaries, and you'll get imaginary numbers as part of your answer. All right, so if our one solution is 2 plus 3i, that means x equals 2 plus 3i. Our other one is x equals 2 minus 3i. We need to change that to the factors. So remember, why it's the opposite sign is because now we're unsolving, we're moving it back to the x. So the signs change. So this actually becomes x minus 2 minus 3i. All right, and when I move this over, this one becomes x minus 2 plus 3i. All right? Because whenever I'm moving it to the other side, my signs change. Now to multiply this one out, it's going to get a little messy, so just stay with me. But notice I have 3 terms in each, x, -2, and -3i. So it means I'm going to have a lot of distributing and combining. So first I have x times x, x squared, x times -2, -2x. X times 3i is 3ix. Okay, and if you're someone that likes a little more organization, you can do a 3 by 3 box, whatever. Now I'm going to distribute the -2 through. So -2x, +4, -6i. And now I'm going to distribute the -3i through. -3ix, +6i. Sorry, I ran out of room over there. And then a -9i squared. All right, and then we'll simplify. Okay, so let's see here. The 3ix and -3ix cancel out. Sayonara. The -6i and the +6i cancel out. So let's see what we're left with. I've got y equals x squared minus 4x. And then I've got the +4 and -9i squared, which, guys, we know is really just -9 times -1, or a +9. Right? So 4 plus 9 is 13. And when you look at this, you shouldn't be able to factor it back out because there aren't 2 numbers that multiply to 13 and add up to -4. If I was able to actually factor my answer, I wouldn't have gotten imaginary solutions. All right, so we will do more practice with this in class on working backwards. All right, the last thing we're going to talk about is converting between the 2 forms, converting between standard form and vertex form. Okay, and the directions are right here for you. So converting from standard to vertex form. All right, so you're going from when it's written out in a trinomial to our beautiful vertex form. So we know A, B, and C, and we want A, H, and K. Well, A is equal to A. The dilation, no matter what, is that for you. So if you're given a coefficient in front of A, that's your dilation factor on the outside, okay? So to find the X value, that's your H, right? Remember, this is the X value of the vertex. So to find it, we're just going to do -b over 2a, just like we did before, and then solve for the Y value. So we've done this before, okay? And then we just substitute our values in. So you'll see in this example, here's our problem. So the 8 is our A. To get the H, all we're doing is, or the X value, we can call it that, we don't have to call it H, but the X value of the vertex, -b over 2a. So the opposite of -16, which is a +16, over 2 times a, 2 times 8, and we got 1. That's the X value. Then plug that back in like we did here to get the Y value, which was 19. So then when you substitute it, here's your A, your stretch, X value of the vertex, the Y value. Okay, so I'm going to go ahead and do the first one, and then I want you to try the next 2 on your own, and we'll go over them in class. So you can either pause the video or just do it. There's one more quick slide. You can do it at the end. But let's see here. Here's my A. To find the X value, I'm going to do -b, so the opposite of -10, which is +10, over 2 times A. So X is equal to 1, right, because 10 over 10. So I'm going to plug that back in. So I have Y equals 5 times 1 squared minus 10 times 1 plus 37. So Y equals 25 minus 10 plus 37. It looks a lot bigger than it really is. Yeah, okay, I'm just making sure my signs are good. 25 minus 10 is 15. 15 plus 37. Oh, that's an ugly vertex. That's okay. I'm not going to make you graph something like this by hand, don't worry. But that's 52. And please let me know if I did something wrong, because it is always possible. So when I write that back out, I get Y is equal to 5 is my A. The X is -1 squared plus 52. And I did do something wrong. Why didn't you stop me? Sorry. 1 squared is 1 times 5 is 5. You're probably like, where did that 25 come from? Or you made the same mistake. Anyways, 5 minus 10 is -5 plus 37 gives you 32. Sorry. Knew it seemed a little too big. All right, so go ahead and try the next 2. We'll go over them in the beginning of class. And I'm going to move on back, going the other direction. Guys, it's just foiling things out. All right, when it's given into you in vertex form, it's saying, hey, you've got 2 of these, so I write it out twice. Foil first, distributed the A through here, which was the 5, and then combine my like terms. Okay, so as long as we're good at foiling, you're good. So this first one, I have y equals x minus 2 twice. So I get y is equal to x squared minus 2x plus 4. So y equals x squared minus 4x plus 10. So that is from standard form to, from vertex to standard, and we could go back the other way. All right, so go ahead and do those 2, and then we'll do go over these in class, and then we'll start off with a little bit practice on all 3 of these concepts before we move on. That is all.